Okay, today I'm going to go through an IGCSE paper. It's from June 2024. It's the Physics Edexcel IGCSE. It's the paper 2. So if you're doing combined science, you don't do this paper. The Physics IGCSE students do paper 1P and then they do 2P. Okay, there's also a regional version. So look out for whether it's 2P or 2PR if you're looking for the mark scheme. Okay, so I'm just going to run through this. There's the original formula sheet that used to be given before COVID. After COVID, they give you a more complete formula sheet and you can download it from the Pearson Edexcel website. Okay, so the first question is about Hertzsprung-Russell diagrams. Okay, so Hertzsprung-Russell diagram shows the how to classify stars according to their luminosity or absolute magnitude, and the color. Okay, so the color tells us something about the surface temperature. So color is linked to the surface temperature. So for example, our sun has a surface temperature about 6,000 Kelvin for our sun. But different stars have different surface temperatures. 3 regions on the HR diagram have been labeled P, Q, and R. See, they have different regions here where the different types of stars exist in terms of their brightness, luminosity, and their temperature. The boxes show the 3 regions. The boxes below show the 3 regions on the HR diagram, and different types of astronomical objects here. So you've got to draw a straight line. That means you need a ruler from each region to the type of astronomical object contained in that region. Okay? So P is a white dwarf star. So you see P, the ones that are gathered here, they have high temperatures because, believe it or not, the temperature increases this way. So temperature is higher temperature here and lower temperature. Let me just change the color for that. So here is high temperature, and on this side is lower temperature. And these P are the P group of stars, which are low in brightness but high in temperature, are the remains of a dead star. Okay, so we call them white dwarf stars. So you need to get a straight line between here and here. Now my Apple Pencil does that. And then Q on the diagram are called main sequence stars. So you see here, the normal stars which are burning hydrogen as fuel are in the main sequence section of their life. So I'm going to draw this one in a different color, and Q is a main sequence star. Okay? And R starts with, let's do it in green. R, these are red giants. Okay? So R are red giants. So we draw them there. So you would get 3 marks if you get those 3 lines drawn straight between the right letter and the right astronomical object. Okay? So you need to know what all of those astronomical objects are. Then it says, define the term absolute magnitude. Okay? This is used for comparing the luminosities of stars in a fair way. So it's a measure of brightness, at a standard distance. So astronomers know how to work out the luminosity of stars using mathematics, and they say, well, what would happen if they were all the same distance away and the standard distance they choose to use is 32.6 light years away. Yeah? And then they can say, well, actually this star appears brighter, but it's only because it's closer. So that what they're trying to do is to say, okay, this type of star is brighter than this type of star. Okay? So that's the first question on astrophysics. 5 marks to get you started in this GCSE. And there's the mark scheme that you can have a look at. And number 2. Number 2 is about moments. And moments is the turning effect of a force. Okay, so you can see, for example, there's a force here which is pulling upwards with a force of 28 newtons, but its line of this force, the dotted line, continues the line of action of the force. So every force has a line that it acts through, and you can see it's trying to turn the nut. It's trying to turn the nut this way. Yeah? It's trying to turn it anti-clockwise. So you're pulling the wrench upwards, and it's trying to rotate the nut around the thread here. And you can see that there's a distance from the line of the force to the center of the turning point, which is the nut, the center of the nut. And that distance, which I've drawn at right angle, is always used. It's the perpendicular distance, which is 15 centimeters, which means it's 0.15 meters. So a wrench is used to turn a nut, and the direction of the turning is clockwise or anti-clockwise. In this case, it's anti-clockwise because the force is going that way. And it's going to turn, so it's going to be anti-clockwise. So it causes a rotation. The force applied to the wrench is given, 28 newtons. They want you to calculate the moment, yeah, that I just explained. So remember, moment is force times the perpendicular distance that I just explained to you, yeah, which means at right angles to the line of action of the force. So then you put those numbers in to this equation, and you're going to get the answer 28 times 0.15 as 4.2 Newton meters. The unit for moments is Newton meters. Okay? So that comes from the forces topic, and it's only in the second paper. The people doing double science don't need to do moments, but you need it if you want to do A-level. Okay, so if you're thinking of doing A-level, you can do A-level from double science or triple science. We do it in A-level physics as well. State 2 changes. State means just say them. That could be made to increase the size of the moment. Well, obviously there's 2 things in the formula. Force, so you can increase the force, or you can apply the force further from the nut. The perpendicular distance needs to increase. So you can increase the perpendicular distance, so you apply the force further away. So for example, if I do it in a different color, if I applied the force at the end of the nut and used 28 newtons here, it would actually turn more easily because the force is at a greater distance to this line of the force that we are drawing at right angles. Okay? So same force, but further away from the center of rotation increases the turning effect. And that's what moment means. Okay. Part C says diagram 2 shows the wrench as it is turned through 90 degrees. That's a quarter of a circle. Yeah, so it's gone from here round the curve to there. So it's gone round a quarter of a circle, and you can see this is the distance to the arc of the circle. So you could say that's the radius of the circle. So the force is applied over a distance that is equal to a quarter of the circumference of a circle. The circumference of a circle is 2 pi r. Yeah? And so you could work out what distance it's moved through. If it moved through the whole circumference, it would be 2 pi times 0.15. You need to put it into meters. Okay, so you want this in meters. So I've changed that there to put it in meters. Okay, so now that they've given you the formula here, but the distance traveled is a quarter of a circumference, because it's only done 90 degrees. To do the circumference would be 360 degrees. So you then you divide the answer to the circumference by 4, and you can get an answer in your calculator to 0.236 if you use 4 significant figures, but you can't really quote it that accurately. You should really use 3 significant figures or even 2 significant figures, because the data provided is 2 significant figures. Okay? That's how accurately we know our values, how precisely we know the values, I should say. Okay, so calculate the work done, okay, by this force as it turns through the quarter of the circumference. So work done is also force times distance, but this time it's not a perpendicular distance. You'll notice in this diagram that the force, and as you're turning, the force is in the same direction as the movement. At first it's moving that way, here it's moving that way, yeah? Here it's moving that way. So the force and the direction, I'm going to draw the direction again in green. The direction is that way. The direction is that way. So the force and the direction are going in the same position, in the same angle, okay? So to do work done, although you're multiplying newtons, yeah, by meters, the answer will come out in joules. Okay, so when they're both in the same direction, which I've underlined here, in the same direction of the force, then you're doing work done. Whereas if it's at perpendicular, then you're doing turning effect or moments. Okay, so it's 24 times 0.24. Yes, I've used the distance of in meters, so I've changed it from 24 to 0.24, because if you want the answer in joules, which they're asking for, and you do it in centimeters, you will get the wrong answer. Okay, so 6.6 joules. There's 10 marks from that question, so you can have a look at the mark scheme, and you can stop the video if you wish to have a look longer. Okay. All right, so the next question is question 3, and it's looking at a scientific method of investigating. So when you're investigating something, you have to be scientific. So the student investigates how much infrared radiation is absorbed by different surfaces. The photograph shows some of the equipment available. So they got a black bottle, dull black, shiny silver bottle, same size, to make it fair, an infrared heater, and 2 thermometers which look like they're identical. So that's the equipment. The student pours some water into each bottle, hopefully the same temperature, to make it fair, to make it valid. Describe a method the student could use to investigate how the color of the bottle affects the amount of radiation, infrared, absorbed by each bottle. You may draw a diagram to help your answer. So use the equipment shown in your diagram. So for example, you want to make sure your method is valid. So in your diagram, you should make sure that you're controlling certain variables to make it valid. So controlling variables makes it valid. If you don't control variables that that could make a difference to your results, you get incorrect conclusions. So you need an equal volume of water in each flask. They need to both be the same distance from the heater. Yeah? You want the same starting temperature of the water. Yeah? In each bottle. And, of course, you need to measure it with the thermometer. Okay? So, I'm not sure the measuring bit should be here. I suppose the measuring bit maybe you could put in the method. So you need to take measurements, so the amount of water and then the temperature change. And do it for the same amount of time, obviously. Repeat and calculate the mean temperature rise. Yeah? So whenever you repeat, don't say I'm going to repeat the experiment. Why do you repeat it? So you can get an average. What kind of average? You want it to be the mean average, not the mode or the median. You want the mean average. Okay? And obviously you're measuring it with the same thermometer, accurate to the same number of degrees centigrade. Now the method must also be safe. Yeah? So safety, you need to consider risks. Consider any hazards or risks. The hot water could burn you. Anything sensible, and that would possibly help you get a mark. And how to avoid these risks. Yeah, you need to give clear guidance, and we'll look at the mark scheme to see what they're looking for. The method must be clear and detailed. So state the range of data you're going to collect. So I'm going to keep the heater on for 5 minutes and measure the temperature every 30 seconds. Yeah, so what readings are you going to take? How many readings are you going to take? Yeah, and that's the level of detail that will get you more marks. Now let's have a look at the mark scheme. Yeah, straight away. So the idea of equal volume, we mentioned. Both must be the same distance from the heater. Same heater output, obviously, for both bottles, because if they're different distances, they won't get the same amount of energy intensity. Same starting temperature, we got that. Measure the temperature of the water in both bottles after a given time, or every 30 seconds might be good. Up to 5 minutes, say. Repeat the investigation more than once. They'll give you a mark for that. But the reason you do it is to calculate a mean. So get into the habit of whenever you say repeat, calculate a mean. Yeah, so keep the heater going, do it again, replace the water. Yeah, they're accepting average on this occasion, but remember there's 3 types of average, and what you really are doing is you're calculating the mean, where you add up your data and divide by the number of times you repeated it. Okay, safety, burning, scalding or electrocution if electricity is involved, and then take care to avoid burns from the heater. Those are the kind of things they're looking for. 2 lines drawn to increase the temperature. Oh, this is the next part. So they haven't gone in any more detail. You could also add something about the range of data that you want to collect. Yeah, which the mark scheme hasn't included, but for future reference. Now, once you got your data, what are you going to do with it? So it says the student plots a graph to show how the temperature of the water in each bottle varies with time. Draw 2 curves. So it's telling you you're going to have curves. Normally when you have heating and cooling, as the temperature increases, the rate of cooling changes. In this case, it's not able to heat up as fast at a high temperature as it is at a low temperature. To show the expected variation in temperature of the black bottle and the silver bottle. Okay? Label your curves, both of them, with the color of each bottle for the second mark. So imagine you start to say room temperature is about here. Say that's room temperature. Now, which one's going to absorb more heat faster? The black one. So let's draw the black one first. So the black one will reach a final temperature which is higher. Yeah, well, it will heat up quicker. And the silver bottle, let's do that as yellow, will go slower. Doesn't mean it can't eventually catch up if you did it for long enough, but the black one will be faster. Okay, and that's your 8 marks. Because the reason is the silver reflects most of the radiation, and the black absorbs most of the infrared radiation. Yeah, so infrared is electromagnetic waves longer than the red, so we call it infrared. Okay, so this is what we're looking for. They're looking for the 2 lines drawn, increase in temperature over time. Yeah, so I suppose you get 1 for each one. Ignore starting temperature. Well, they should start from the same temperature. Yeah. It's not very clear what they're giving the 2 marks for. I suppose 1 for each line. And then identify, oh, this is it. The line identified candidate as black is always above the line. Yeah, so the black line, there's your second mark. The black line is above the other one. What I didn't do, I might lose a mark, I didn't label them. Yeah, so this is the black and this is the silver. Okay, obviously you're not going to be writing with a highlighter pen like I am. I apologize. Okay, so we've done 3 questions. Now we're doing question 4 about electrostatics. Polythene rod rubbed with a cloth causes both rods to become charged. How does it work? By transfer of electrons. Which of these is the force that causes the rod and the cloth to become charged? The answer is friction. Yeah, so whenever you rub one surface with another, electrons are being rubbed off one of the surfaces and they'll go to the one they're attracted to most. Polythene rod becomes negatively charged. That means it's gained electrons because electrons are negative. Yeah? The one that gains the electrons becomes negative. The one that loses the electrons loses negativity. Okay? Protons are in the nucleus, I've written here. So it's got nothing to do with C or D. It's got to be A or B. And it says which statement explains how the rod has become negatively charged. To become negatively charged, it gains electrons. So there you go. The answer is A. Then question B says the student has rods made from different materials in the table. The student rubs each rod the same way with a cloth. Yeah? Hopefully the same cloth, because different cloths are made of different materials. The student measures the charge gained, 3 times, and then works out the average. And they have measured the charge gain in nanocoulombs, 10 to the minus 9 coulombs, a billionth of a coulomb. Now, a coulomb is a huge number of electrons, 10 to the 18 or more. So you see they've done it 3 times and then taken the average as the mean average, which we were talking about in the last question. So once again, it's scientific methodology that they're looking at. Okay? Note that we got positive and negative readings in the charge. So the glass has become positive, whereas the other 3 have become negative. And they've left this one for you to calculate. So you've got to add these 3 numbers up and divide by 3 and put the value in that box. Okay? One of the readings for the polythene is anomalous. So they want you to look at the readings for the polythene and circle the anomalous one in the results table. So polythene, which one is anomalous? So 61 and 59 are close together. There's the anomalous one. Okay? Then show how the student should deal with the anomalous result. So if you know it's definitely something weird about it, you take it out and then you can calculate, you can ignore it so you don't use it. Yeah? And then you can calculate the mean with or without the anomaly. And I think you'll get 2 marks if you do it without the anomaly, because you'll be closer to the true value. And the whole reason for doing investigations is to try and get closer to the true value of what the charge will be on each one. So you would take only the 2, 51 and 69, and in here you would write minus 60, because the average of 59 and 61 is 60 nanocoulombs. Okay? All right, so hopefully I've got it right. And then you write it in there. And you should show you're working really. And then it says, describe how the student could, this is a very common question in paper 2, use the rod to demonstrate that there are two different types of charge. So what apparatus would you need? Well, obviously you would need to charge one rod, and normally you would suspend a charged rod so it's isolated from anything else. So you could use some thread to hang it from the ceiling, yeah. And you've got to show if there's two types of rods. So this is polythene, which was negatively charged, and you let it stay hanging as negatively charged, and then you charge another polythene rod and you bring it close to the suspended one, you should get repulsion, okay? And then say you brought the glass rod, see here, the glass rod was positively charged, had a mean charge of plus 36. If you brought a positively charged rod close to it, you would get attraction. So the glass rod would attract. So you need to say that opposite charges will be attractive and like charges will be repulsive. So these are the points that you need to make to get 3 marks. What about a neutral object? Just to think about it. A neutral object will be attracted or will attract the charged object, okay? Because they're different charges, really, yeah? So charges will always move to equalize if they can. So if there's one charged and one neutral, the charge will go to equal the charge on the neutral object, or try to. There's 9 marks for this electrostatics question. Let's have a look at how we did, okay? So this question, I want to show this part first to discuss alternative apparatus and methods. Suitable apparatus, I think mine was, to show that the rod is charged. You can also use alternative methods as shown here to show that the charge is rodded, the first rod that you've charged, that you suspended from the ceiling, is charged, because obviously if it's not charged, you haven't rubbed it enough. So the first thing that you should do perhaps is to do that, and I didn't put that in, so maybe I'll lose a mark. So you could do, what I always show my students is that when you rub using friction a cloth with a rod, the rod will be charged, and if you hold it next to a stream of water from the tap in the lab, the water, which is neutral, will bend towards the charged rod, okay? Then you need to indicate that a charged rod will apply a force on other objects. So again, you could do the water stream bending, yeah? And that will always be attractive. It will always be attracting the neutral object, yeah? So the charged object will attract the neutral object, or whichever one it will be free to move, will move towards the other. Then you've got to show evidence that there's both attraction and repulsive forces if you use opposite charges and if you use like charges. So I kind of concentrated on that, and maybe I haven't given enough detail for the fact that I think I'd get 2 out of 3 easily, but maybe I should have said you've got to make sure that the initial suspended one is charged, okay? You could also use a Coulomb meter, which is what they were using to get the answers in nanocoulombs, yeah? So there are different ways of doing it, but my method is the standard method, okay? And there's the first part of this question that we went through before. If you want to stop the video, you'll be able to see how well you did. Okay, so the next question is about sound. Which wave property determines the pitch of a sound? So that's the frequency, yeah? So over here you would just write frequency. We only use the word pitch for frequency when we're talking about sound. Frequency is the more scientific word and it's measured in hertz. Here they've put the frequency in kilohertz, which means multiplied by 1,000. And it's written, the chart shows the maximum frequency heard by 4 animals and a human. And they want you to determine which is most likely to show the results for a human. And the answer is maximum for humans, is 20,000 hertz. So that's C. Yeah? Humans can't hear above 20,000 hertz. Okay? See here they've mentioned the maximum frequency. So maximum frequency, you've got to pay attention to the exact wording. Explain which of the bars is most likely to show the results for a human. It's C, yeah? And you've got to say maximum frequency is 20 kilohertz for humans. So I'm guessing you'll get 1 mark for saying C and 1 mark for explaining it. Okay? So you can look at the mark scheme and see how I did. Let's go straight there. Frequency C is chosen because humans can hear only up to 20,000 hertz. So I got the 2 marks there and the previous marks too. Now we're going to look at sound, a frequency 500 hertz, and we're going to show that the period is about 2 milliseconds. Well, T equals 1 over F. So 1 over 500, if you put it in there, you will get that answer to standard form. You can leave it in standard form. Okay, so the diagram shows the screen of an oscilloscope, and an oscilloscope is measuring voltage up here and time across. And the time is set to 0.5 milliseconds per square. So that's the horizontal axis. So each of these squares is 0.5 milliseconds. 0.5, 1 milliseconds, 1.5, 2 milliseconds. And remember, the period of the wave was 2 milliseconds. That means 4 squares will be 2 milliseconds on the center line. We normally draw it on the center line because the center line is 0 volts. Above is positive and below is negative. So if you like, the displacement for sound on an oscilloscope will be voltage against time because a microphone changes the sound into voltage. Okay? Draw the trace on the oscilloscope when the sound wave is detected. They're talking about the 2 millisecond sound wave. They haven't said how loud it is, so as long as you draw it with the period being 4 squares, have I drawn it wrong? Period should come up there, so let's get rid of that. Draw it again. So I want it to, peak, 0, trough, full cycle. And then it would repeat that cycle. 1, 2, 3, 4. 1, 2. I haven't drawn it very well, it should be smoother than that. So here we had 4 squares, each square is 0.5 milliseconds. So from here to here is 2.0 milliseconds, and that's the period that we calculated for a frequency of 500 hertz. And that's how you can use oscilloscopes to determine the frequency from the period. Okay, so in this case we're talking about milliseconds. Okay, so we got 4 squares to complete 1 wave. And there's the mark scheme. And they've only drawn 1 of them. Yeah? Okay, next question. It says it's about electromagnets. Describe the construction of a simple electromagnet that is producing a magnetic field. So, what apparatus do you need to make an electromagnet? Yeah? Well, you need something to make a coil with, so insulated wire, for example. You could go copper wire, and then in between it, you could put an iron nail which increases the strength of the electromagnet. You wrap it round. What else do you need? Well, you need electricity. So imagine the yellow wire is the coil, and then you could attach that to a cell. And the current is flowing, and if you wanted to, you could put a switch in there so you can stop it from overheating. Now, so I don't know what they're looking for. Describe the construction. So the more turns you have, yeah, so you need to label it probably. So you shouldn't just leave a diagram like that, but you can see you've got a cell, you've got a coil with n turns, and the more turns you have, the stronger the effect. And then you have the current makes an electromagnet. Now this could be a 1.5 volt cell which creates the current which produces a magnetic field. So, describe the construction. So you've got to put everything I said into words and get 3 marks. Let's see what the examiner says. So, coil of wire. Yeah, we got that. Current. We got that. Iron core. We got that. So I used a nail for an iron core. And that increases the strength of the magnetic field by 5,000 times approximately. Okay, so that we would have got, I think we'd have got 3 marks. Okay, so once we've done that, the next bit of the question says a proton, positive, moves through a uniform magnetic field. That means the strength of the magnetic field is constant, and it says here the magnetic field is acting into the page, which is always represented by an X. Yeah? So if you look at a dart, when you're throwing a dart, the back of a dart looks like an X, yeah? And if you saw a dart coming towards you, you'd see the front of the dart as a point, yeah? So if the point is coming towards you, you put a circle with a dot in it. And if it's going away from you, you can put an X going away from you. You can do it for current or for magnetic fields, okay? Then it says the shaded area in this diagram, the grey area, represents the area of the magnetic field, and the initial velocity of the proton is shown. So the proton is going this way initially, and then you're going to use Fleming's left-hand rule, where the proton is equivalent to the current direction because it's a positive charge, and the conventional current is a direction that a positive charge would move. So the second finger has C in it. So the current is the second finger. So you put your second finger in the direction of the current. And then the field is going into the page. So your first finger, yeah, into the page. So that's the first finger, second finger. And therefore the thumb shows you the directions. You've got to use the left-hand rule. If you put your first finger into the page, the second finger in this direction, you'll see your thumb is pointing upwards. So the force is going to be upwards. Yeah? So basically what's going to happen is it's going to start going that way. And the force is always, as the proton is moving, changing direction, then the current is also changing direction, so you need to adjust it to as it's changing direction on these yellow lines. The force will always be later on at right angles to the direction of motion. So I'm going to draw the force now as green. And later on the force will be that way. It's always at right angles. That's what Fleming's left-hand rule shows you. The force is always at right angles to the moving charge or the current. Okay, the magnetic field doesn't change. So it says use Fleming's left-hand rule to determine the direction of the force acting on the proton, which I've done. So I'll get the 1 mark. Okay, remember proton direction is positive, so it's conventional current. So if it was an electron, you'd have to reverse it because the electron's negative. Explain how the force on the proton changes as the proton moves through the magnetic field. Well, that's what I was explaining to you. You can add to the diagram to show that it's going to have a curved path. Yeah, the curved path is going to go, let's change the color to blue. It's going to go this way and eventually go that way. And then the green arrow, let's get rid of this green arrow. And the force is always going to be, the force is always going to be, oh dear, I lost it. So we're going to leave that. The force is always going to be at right angles. So here it will be that way. Here it will be that way. So force is always at right angles to the direction of the charge movement, which is current. Okay? And if the magnetic field is strong enough, you can actually get it to go in a full circle. So if it started here, you could actually get the movement to go like that and back out again. Yeah? Hope that makes sense. So you got to explain the way I did. The idea of this circular motion or centripetal force, you've got to explain that the force is always at right angles to the direction of the moving charge. So you've got to mention the moving charge, yeah, and that they're relative to each other. So you've got to say the force is always at right angles to the moving charge. So you're going to get basically a curved path, part of a circle. Now let's see how many marks we'd have got for that. So the idea of upwards towards the top of the page, we got that. And any two from the force always at right angles to the velocity or the movement, the direction I said, causes the proton's direction to change, yes, because the proton motion is equivalent to a current. Yeah, the direction of the force on the proton changes. Yes, this causes the direction of the force on the proton to change as it changes direction. Yeah, but the size of the force is constant. Now I think we would have got full marks. Yeah. Have I? Maybe not this one. I didn't mention that. The velocity changes because the direction changes. So where did I miss out that? Oh, it's the next part. Suggest why the velocity of the proton changes. So that's the next question. So the velocity is changing because the direction is changing. I'm getting better with my Apple Pencil practice, I suppose. There we go, we've done all that part. Another 7 marks done. And aim is to do this in one sitting. The hydroelectric power station generates electricity from renewable energy resources. Okay? So obviously the rain comes and fills the lake, yeah? But then they also, I think they can pump it up to the top as well if they wanted to. So you've basically got water with gravitational potential energy as a store of available potential energy. Yeah, that's what potential energy means. And this gravitational energy, potential energy, can do mechanical work for you if you let it come through this pipe and to turn this turbine, which is connected to a generator. And then the generator can make electricity, which you can then send to wherever you want through the national grid, held up by the pylons. And then the water ends up in a lower gravitational potential energy state, where it's less useful in terms of producing energy. Water flows through the turbine. So that changes the potential energy gravitationally to kinetic energy. So you've got a store of gravitational potential energy, then it goes into the kinetic energy store as it's moving. Yeah, so they love this word in GCSE now. They never used to use it, but it's becoming a lot. In your GCSE, you need to make sure you distinguish between energy transfers and what energy it is stored in at the time. The turbine is connected to a generator, which obviously generates electricity. Okay? Describe the energy transfers. So you see, the energy transfer is gravitational, loss of gravitational potential energy is transferred by a mechanical work. Mechanical work means doing some physical force produced in terms of the work done by the gravity to do some mechanical work to gain the kinetic energy of the water, and then later on the water is doing, through this loss of gravitational potential energy, is doing mechanical work to turn the turbine. So whenever a force is involved, we say it's transferred by mechanical work. Okay? So then you've got to mention the generator, and you've got to mention some wasted energy. It's not going to be 100% efficient. It won't be. So not 100% efficient. You will get some wasted energy, not 100% efficient, I should say. So let's have a look at what they're looking for. Idea that the source will not run out. Where they asked about renewable. Oh yes, I didn't explain this bit. Renewable energy source means that it's never going to run out. It's not a finite resource. Okay? Water has gravitational potential energy. Yeah? Water loses gravitational potential energy and gains kinetic energy. We got that. And it transfers mechanically. Yeah? Either to the water itself, or the turbine, or the generator. This is all physical work done. Yeah? And remember, work done from an earlier question is force times the movement. In this case, it will be circular movement. Yeah? Which we talked about earlier. Energy is transferred electrically from the power station. So this is electrical work done, yeah? And this time the work done is actually moving charges. Q times V does the electrical work, or we should put W. W, electrical work, is QV, mechanical work is force times distance. And then you need to mention that some energy is wasted somewhere. You're going to get some sound, yeah, from the movement of the water. That energy doesn't end up where you want it to be. It's kind of lost to the surroundings. And whenever there's movement, there will be some energy lost as heat, yeah. So there's many ways, five ways to get the marks, okay? So we were on part B, part C is coming up next. So here's the mark scheme for part C. You can come back and have a look at it whenever you want. And we'll have a look at advantages and disadvantages. Looks like the HE hydroelectric power station is located near a wind farm. Give one advantage of generating electricity using hydroelectric power rather than the wind farm. Okay? Well, the hydroelectric power station, if it's got water at the top, is more reliable, yes, that you can just basically release the water when you need it. Yeah, so reliability is one thing. And one disadvantage of generating electricity using hydroelectric power station rather than the wind farm. What are we going to put for that? Disadvantage of generating electricity using hydroelectric power station. I don't really know what to put. So any three, it says, oh, it was in the previous one, right? C part 1, C part 2. Yeah, so more reliably we'd have got that. Yeah. And then disadvantage, that's what we're looking for. Needs a large area of land to be flooded at the bottom. Yeah, I don't see that as a big disadvantage. So it's location dependent. Yeah, you need a mountainous area. Yes. And it can damage the habitats. For example, if you're using a natural water system and you're damming it up, then the fish or the animals can't use it. So yeah, you got to think of things like this. I don't really, I'm not very good at doing this kind of question. Yeah. So any common sense point. And when you do enough papers, you'll see that these come up in paper 2 quite a lot. Okay, the hydroelectric power station uses an electric pump that can pump water from the lower lake back to the upper lake. The pump can be powered using electricity generated by the wind farm. So, say you're not using a lot of electricity at times, so at low demand times, you think, hang on, it's windy, why don't we use our wind energy to pump the water back up to the top? Explain how the hydroelectric power station and the wind farm can be used together. That's a form of getting more out your two systems. I call that synergy, yeah, to maximize the effectiveness of generating electricity. So when we have low demand, you use the wind energy, yeah. So low demand, use available wind energy. So take the opportunity to pump, yeah, the water to the top lake from the bottom lake. Why? Because if you do that, then when you have high demand for electricity, you can release it from the top lake. So the top lake, yeah, so then you can get extra energy. So because wind energy can't be stored, so it's good when you got it to be able to pump it up, and then when you've got like a useful store of energy which you can use on demand. Yeah? So wind energy can't be stored, but the water can be stored using gravity. And the pump allows you to do that. And if the wind is giving you free energy to run the pump, yes, then you can get the best of both worlds. Let's have a look. Any three from idea that the wind cannot store energy, we mentioned. Idea that the wind powering the pump, we mentioned. When the demand is low, we mentioned. Idea that therefore that the upper lake acts as an energy store, yeah. So the wind can be used to store its energy in the form of gravitational potential energy. So you're doing mechanical work or electrical work in the pump to physically do mechanical work to push the water back uphill. Yeah? So electricity is part of the electrical work that's needed. And then energy is released from the upper lake when the demand is high. So only 3 marks and we've already got 4. So the idea that more electricity is then transferred usefully. Yeah? I don't know what they mean by that, but you can decide for yourself what you've written. We've already got the 4 marks or the 3 marks. Here you got a water bath, yes, so it's a way of keeping a controlled temperature, yeah, so they use it a lot in biology to heat some water. In this case, the water bath is filled with water at an initial temperature of 15 degrees centigrade. You've got to change it into Kelvin. That means you've got to add 273 So you should 273 plus 15 becomes 288 Kelvin. It's only a 1 marker. I wouldn't worry too much about that. So this is about specific capacity, this question. So you can see the solids, liquids and gases. The technician heats the water to a final temperature of 60 degrees. Was it 15 before? So it's gone up. The temperature difference is given to you here as 45 degrees centigrade or Kelvin. 1 degree centigrade is equal to 1 Kelvin. And then it's got describe how the energy of the water molecules changes as the temperature of the water increases. So as the temperature goes up, the temperature in Kelvin is proportional, directly proportional to the mean kinetic energy of the particles. That's mainly true in gases, is a direct proportion, but in water molecules it will also hold true. Increased temperature, you increase the kinetic energy. Okay, so let's have a look at part B1 in the mark scheme. Yeah, so the energy increases, kinetic energy increases, we got it, yeah? And then it says calculate the energy transferred by the heating element, voltage and current given. So you can work out the power, voltage times current, but they want the energy transfer during the heating process, and it was on for 45 minutes. So you multiply the voltage, the current, and the time to get the energy. So energy is power times time. So what you've got to do in this case is to write E equals VIT, which is 230 times 1.5 times 45 times 60, because it's got to be in seconds to get the units right. It's got to be in seconds. Okay? Once you put those numbers in your calculator, let's see what the examiner got. 230 times 1.5 times 2,700, because we've got multiply the time by 60. So we got the multiplication of 60. We use the equation, put the numbers in, and the answer in your calculator should come to this. And you leave it in standard form if you want to. Here they said you can also write it out like that. 9.3 times 10 to the 5 joules. 9.3 times 10 to the 5 joules should write in there, and it only requires 2 significant figures, okay? Because the data provided is all given in the table to 2 significant figures. So that's as accurate as you can be, okay? Now, the next bit, it says calculate the mass of the water being heated. You've got to use this equation because it's specific heat capacity. So the water is being used. This energy is from there. So we know the energy. We know the specific heat capacity is given to us. It's always about 4,200. So we know the energy. We know the value for the specific capacity, and we know the temperature rise. So all we got to do is write out our answer, 9.3 times 10 to the 5 divided by 4,200, and the temperature change was 45, wasn't it? And then you put in your calculator, and we're just going to use the examiner as our calculator. 9.3 times 10 to the 5 divided by 4,200 on the bottom times 45, which came from there. and it will give you 4.9 kilograms, again to two significant figures. Okay? So try to stick to the right number of significant figures. 4.9 kilos. So it equals 4.9 kilograms, two significant figures. And there you have it. Question 8 complete. 8b complete. Now 8c. Some water evaporates. Well, water evaporates from the surface. Yeah? Describe the arrangement of particles in the gas. Well, they're free. They move randomly. Oh, I don't know how that did it. Free, random motion. Yeah. What else can we put? Free, random motion. Yeah. Let's have a look in a minute, see how many marks we get. Free to move, random motion and move fast. High speed. I'm writing with the highlighter, sorry. Describe two differences between evaporation and boiling. So evaporation happens at the surface only, whereas boiling happens throughout the liquid. Obviously, it's the liquid that boils. So when you see the water boiling in a pan, you can see all the bubbles. Well, that's actually water changing into steam at anywhere in the water, where normally you don't see the evaporation happening at the surface. It's happening molecule at a time. Okay? And there you have it. You have finished the paper. 70 marks. It should take you 75 minutes, I think, they give you. And the final bit. Particles are arranged randomly, we got that. Particles are spread out or widely spaced. Yes. I didn't get all the marks. Yeah. Condone moving. So maybe I only got 1 mark. Yes, spaced out. Yeah. Anyway, there you go. Boiling happens at a specific or fixed temperature, but evaporation happens at any temperature. Yeah, I didn't get that. Boiling happens throughout a liquid. Evaporation happens only at the surface. You're right, boiling only happens at 100 degrees centigrade. So I'm losing marks. So, see, it's easy to lose marks when you are going through an exam under time pressure. So, I'm going to put this on FPL Physics and the nature of reality. And if you go to the home page, and you look for playlists, this is the IGCSE 2024. All the IGCSE 2024 papers are together. There's 2 paper 2s and 2 paper 1s. And for my students, that's your homework this week to do that. So don't forget to like, share and subscribe so more students from other schools also start following, and the more successful the channel is, the more likely I am to do more videos. Okay? Alright, so thanks for watching. Catch you in the next video. Bye for now.